In this short lesson, we are going to learn about what, why, and how about confusion matrix. But before we actually start learning confusion matrix, let's do a quick recap about classifier model. In machine learning, classification is a task where a machine learning model assigns or predicts a specific category or so-called class label to a given input. The left side of this slide shows a single class classifier model, also called a binary classifier. It takes an input such as an email and classifies it into like spam or no spam. So this is an example of a simple single class classifier. The right side of the slide illustrates a multi-class classifier model. Here the model can classify inputs into multiple categories. For example, it takes a customer complaint as an input and categorizes it into one of several classes such as account issue, transaction issues, application issues, or network issues. This is the sample data of the multi-class classifier. So here we can see in the left side, we have text description, which is nothing but the features. And then we have the classification or the category. In the right-hand side, we can see that there are 4 categories out of this sample data. So we start with a sample data set that contains the information we want to use to train and test our model. This data is typically split into 2 main parts, a training set and a test set. The model then learns the patterns from the training data, adjusting its internal parameters to make accurate predictions. Then we use the test data to see how well the model performs on new or unseen data, measuring its accuracy and reliability. During model testing, each predicted result from the model is compared with the actual result to check if the model made the correct classification. In this example, we see that some predictions matches the actual result while others don't. When test data includes hundreds or even thousands of such entries, manually comparing each prediction with the actual label or actual result to calculate accuracy becomes impractical. This is where the confusion matrix comes in. The confusion matrix helps us quickly understand where the model is performing well and where it may be making errors. The name confusion matrix comes from the fact that it shows where the model gets confused when making predictions. In Python, there is this library called confusion matrix and classification report, which does this job. You just need to pass your actual and predicted values and call this function. So what is confusion matrix? So it is an n cross n matrix. Let's try to understand this for our multi-class classifier example. In our example case, we have 4 classes or category. So we have 4 cross 4 confusion matrix like this. Each row of the matrix represents the instances of the actual classification, while each column represents the predicted classification. Let us see how this is populated. Take an example of one class, say account issue, and try to understand the whole process. And then you can repeat the same process for the remaining classes. Let us see the data manually. Let's apply a filter for account issue on the actual value. So only for account issue. Now here we can see there are about 14 record in the test sample where the actual classification is account issue. Now in the predicted results, we can see that out of those 14, our trained model were able to predict 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So out of 14, the model was able to correctly predict only 10 of them. So these 10 where model were able to correctly predict the account issue as account issue is called true positive. So there are 10 true positive. So going back to our matrix, so here this particular cell where you have the row as account issue and column also has account issue. So the true positive value will be updated here for account issue class. Now in the account issue case, as I said, there were 14 sample where the actual class were account issue, out of which 10 were predicted as account issue. The 4 were incorrectly predicted. Now, the ones which were incorrectly predicted are like this. So one of them, in fact, two of them is predicted as the transaction issue, one of them as application issue, and one of them as network issue. Now, all these wrong prediction where the actual class is account issue, but model predicted as something else is called false negative. So for account issue, there are 4 false negatives. Now, where do we update this false negative in the confusion matrix? So this is where the row value, because if you notice in the beginning, I was telling that the row value contains the actual results. So therefore, if you add all of them, so 10 plus 2 plus 1 plus 1, you get total 14, which is the actual account issue samples in the test sample. False negative is also called type 2 error. Then there is something called false positive. This is added as column values, actually predicted as account issue, whereas in reality, 3 of them are transaction issue, 2 of them are application issues, and 1 of them is network issue. So this is also called type 1 error. And then there is something called true negative. This is the count of the instances where the actual class is negative and the model correctly predicted it as a negative. So all these numbers which you see here, which are about 34, in consideration of account issue, they are not predicted as account issue, and which is correct because they were not account issue as per the test sample, and therefore this is called true negative. When you consider all other classes, you will notice that the true positives are the diagonal values. This means that a model is really good if all its predictions are on the diagonals in the confusion matrix. Values far off from diagonals are either false negative or false positive, which is not good. Okay, so now you have all the ingredients ready to finally compute the accuracy, precision, and recall of your model. Now, accuracy tells us the proportion of correct predictions made by the model out of all predictions. So this is the formula of accuracy. So for this particular class, which is account issue, if we use these values, we are getting the accuracy of account class about 81%. Then the precision focuses on the proportion of the correct positive predictions out of all the positive predictions. So it is helpful to understand how reliable a positive prediction is. And this is the formula. Now, if you apply this formula for your class, say account issue, you're going to get the precision for account issue about 63%. Then there is something called recall or the sensitivity, or also called true positive rate. This is the formula. So recall measures the proportion of actual positives correctly identified by the model. It is helpful to understand how well the model captures all relevant cases. So if you apply this formula on your value which you have computed, you are going to get recall as about 71%. And finally, the F1 score, which is the harmonic mean of the precision and recall, as you can see in the formula. It provides a single score that balances both precision and recall, giving a better overall measure for the model's accuracy when there is an unseen class distribution. Now, when to use the F1 score? So the F1 score is particularly useful when false positive and false negatives are both important. So say if your application requires a balance between precision and recall, such as in medical diagnosis or fraud detection, this F1 score is important. And the other situation where F1 score is important is the class imbalance. So when one class is more larger than the other, accuracy alone might be misleading, and the F1 score gives a more balanced view of the model's performance. So for account issue, the F1 score is about 67%. So here is the conclusion. Hope now you are able to understand the confusion matrix. Thanks for watching.